So hello and welcome to a new lecture on statistics, where this time we are going to introduce the concept of distributions, sometimes also called statistical distributions or probability distributions. So what are distributions actually? So distributions can be seen as some kind of a function that describes the frequencies or the number of occurrences of certain outcomes of a random experiment. And in order to illustrate this, we are going to use the example random experiment that was already introduced in the previous lectures, namely the one of the flip of a coin 2 times. And basically the results or the sample space and associated random variables are summarized within this table. So we have basically 4 different outcomes that compose the sample space with their corresponding random variables, x equals 0 for 0 time tails, x equals 1 for 1 time tails, and x equals 2 for 2 time tails, and the associated probabilities, 1/4 for x equals 0, 2/4 or 1/2 for x equals 1, and 1/4 for x equals 2. And with this we are basically ready to draw the probability mass function that was also introduced in one of the previous lectures already, and the probability mass function is actually a distribution. A very particular one, it's a discrete distribution. So let's discuss the probability mass function or distribution of this example again. And we basically saw that the plot is composed by 2 axes. We have an x-axis and a y-axis. So on the y-axis we basically have the probability, and on the x-axis we have the associated random variable x. And we saw that we have 3 different values for the random variables. So 0, 1, and 2. So 0 is somewhere here, 1 is somewhere here, and 2 is somewhere here. And then associated probabilities, we have 1/4 for x equals 0. So we are basically here. Then we have 2/4 for x equals 1. So we are somewhere here. And for x equals 2, we have again 1/4. So basically this is a distribution. This is the distribution of this random experiment of flipping a coin 2 times in a row. And it is a discrete distribution, because discrete means basically that we have only discrete precise values that can occur. If we would actually repeat the random experiment of flipping a coin, let's say 1,000,000 times. So let's say we repeat the random experiment 1,000,000 times. So M stands for 1,000,000. So in general, we would roughly obtain as the number of times where we have 0 time tails, so x equals 0, would be roughly 1/4 of the time. So let's say 1/4 times 1,000,000, which is actually 1,000,000 quarter of a million. Then number of times where x would actually be of the form heads tails or tails heads, so basically 1 time tails, would basically be 2/4 times 1,000,000, which is actually 2 times 1,000,000 fourths, or 1/2 million, half a million. And the last example is actually random variable x equals 2, and here again probability is 1/4, so basically 1/4 times 1,000,000, which is actually 1,000,000 divided by 4, or basically 250,000 times. So that's basically to make the relation between repeating a random experiment and writing down the number of occurrences of a certain outcome, or the frequency of a certain outcome, and a probability. Because what we could actually mention here is that in general we have a probability of some random variable x. It's basically corresponds to the number of times that this random variable actually x occurs, divided by the number of times where the random experiment t is repeated. So basically this was here the number of times t was repeated, And this is actually nothing else than number of times the random experiment takes place, the random variable x takes place over the sum going from some value I to some value n1, number of times x equals y. That's just an additional remark. So basically that was a discrete distribution. Let's go over to a continuous distribution. So in order to illustrate this, we could imagine another random experiment or another situation basically, and namely we could consider the number of people, the age of different people within a certain population. So basically this could, this is here, so basically we have again two axes, a y-axis and an x-axis. And this time we would basically have the number of people with a certain age. And age we would go from 0, so unborn children, up to, let's say, 10, 20, 30, 40, 50, 60, 70, up to 80. And when we consider now Western civilizations, for instance, we have like pretty old populations. So basically we would see a peak around the age of, let's say, 45 or something. So we basically would observe a peak, let's say, at the age of 40. So at the age of 40, we would have most people that have this particular age. And then we would basically see around the age of 40 a certain drop in the number of people. So basically for 30 we would be, let's say, somewhere here, and 20 somewhere here, and 10 somewhere here, and 50, I don't know, maybe somewhere here, 60 somewhere here, 70 somewhere here, 80, and we could even go higher, and 90, etc. But let's stop here. So basically we could then go and relate the different points with the curve. And in general, we also have people that have an age, let's say, for instance, between 20 and 30. So basically, we also have points here that we are not going to show here, but basically we have people in the population that are like 25 or 35 or 47, etc. So basically, we have like a shape that goes like this. And this is basically the typical bell-shaped form of a continuous distribution. So with this, we basically see that we have two kinds of distributions. We have discrete distributions, and we can also have continuous distributions. So in the next lectures, we are going to discuss some very special distributions, and we will then continue to deepen the discussion on distributions. I hope this video was of some use for you. If you like to see more content like this, then please like my video and subscribe to my channel, and see you in the next video.